Slides are visible to you?
Yes.
In the last class, we were talking about variable length coding, and we said that variable length coding is useful when the symbols have different probability of occurrence. Right? Higher the probability, lesser will be the number of bits. So less number of bits. Lower the probability, we can have more number of bits because that would be less probable occurring less number of times. We talked about Huffman coding. What we did in Huffman coding was we arranged the symbols in the decreasing order of probability and then kept on adding the last two entries and rearranging the probabilities at every step and finally giving the code such that one bit was added in every step. Now, when we have more number of symbols, as the number of symbols increase, the number of steps also increase because total number of steps for Huffman coding will always be equal to number of symbols minus 2. So if I have more number of symbols, I need more number of steps if I follow the same thing. So to get that, to reduce that number of steps, we have some variations in Huffman coding. Let us say I have a ternary Huffman coding. What ternary Huffman coding says is that instead of adding just two of the last probabilities, consider three last probabilities together. Right? So let us say I have the word committee given out by the source. So what are the possible symbols that my source can give out? It is C, O, M, I, T and E. So this is a source which gives me these 6 symbols with probabilities given as the probability of C is 1 out of 9 symbols. So the probability of C is 1 by 9, O is 1 by 9, M is 2 by 9, I is 1 by 9, T and E both are 2 by 9. Right? So I arrange the sources in the order of decreasing probability. So since I have 3 equal probabilities, I arrange the symbols as first come first serve. So I have C, O, I, M, T and E, such that the probabilities are 1 by 9 for the first 3 entries and 2 by 9 for the last 3 entries. Now your normal Huffman coding which we did in the last class, it added the, oh sorry, I arranged it in the wrong order. It has to be in decreasing order. So it will be MTE COI 2 by 9, 2 by 9, 1 by 9, 1 by 9 and 1 by 9. Now, in the case of the Huffman coding that we did in the last class, we kept on adding the last two probabilities. Now I say I need to have a non-binary Huffman coding, that is a ternary Huffman coding. So I'll combine these three probabilities together. So the sum of these three probabilities will be 3 by 9. So I'll place this higher probability on the top, 3 by 9, and remove and place this 2 by 9 as it is. Shifting 1. This 2 by 9 comes down here, this 2 by 9 is here and this is here. Now I add the last three smallest probability. This gives me 6 by 9. So I arrange this again in the decreasing order, 6 by 9 and 3 by 9. This comes down here. But now when I am combining three symbols together, three probabilities together, I will have the code defined as non-binary also. It simply means that I can initially I could only have the two cases, 0 या 1 लगाना था मुझे. अभी since I need three codes, because at every step I need to differentiate between three probabilities or three symbols. So I need to have a ternary code. So at every step I add 0, 1 and 2, three symbols or three values for the code. So if I look at the first level here, I have only two options, 6 by 9 and 3 by 9. So I choose to give a code of 0, a code of 0 to 6 by 9 and a code of 1 to 3 by 9. I need not assign this code right now. But in the same way as we did for Huffman, this 0 is propagated backwards, so that this is given as 0, this is given as 0 and this is also given as 0. Now at this level, to differentiate between these three symbols with probability 2 by 9, I append another bit. So I give the three values 0, 1 and 2. Right? 3 by 9 was given the code 1, so it is back propagated to 1. This one is further back propagated here, and to differentiate between these three symbols, I put extra bit and I give the value 0, 1 and 2. This 2 by 9 is already given the code 0, 0. This 2 by 9 is given the code 0, 1 and this 2 by 9 is given the code 0, 2. So now I have two bits only used for each symbol. Okay, but the case is that I have three symbols, three values for each bit, 0, 1 and 2, but the number of steps reduced. So this is useful when I have more number of symbols. The decoding still remains in the same way as we did for normal Huffman coding, where I say my input data is no, I don't have this 2. I'll have 0, 1, 1, 0, 1, 0, 1, 1, 0, 2, 0, 0, 1, 2. So this is my input for decoding. I start with the first bit. I do not have a single code for 0, so I look out for 0, 1. 0, 1 is T. Then I look out for 1. 1 has three options. 1, 0 भी हो सकता है, 1, 1 भी हो सकता है, 1, 2 भी हो सकता है. So I combine the second bit. The second bit is 0. So 1, 0 means it is C. Then I again start with 1. 1 has three options, so I use the second bit, which gives me C again. Here this gives me O. 0, 2 gives me E. 0, 0 gives me M. And 1, 2 gives me T. So this was the word which was sent. Right? The problem with Huffman coding is that suppose I have a case where the sum is 3 by 9 and there is an entry with the value 3 by 9. Now it is my choice whether I put this value on top 3 by 9 or I should assume this value on top. The simple rule that we will be following is that whatever is the lower probability being added, we will always keep the sum below the higher probability. So अगर यहाँ पे already 3 by 9 होता तो I will not have shifted this 3 by 9. Instead, the original higher probability 3 by 9 should have been placed on top, followed by this summation 3 by 9. That would reduce the ambiguity कि जिसका probability कम है उसका length will be higher, उसका length will be higher than the symbols with the lower probability, right? Therefore जो भी हम यहाँ सम कर रहे हैं उसका प्रोबेबिलिटी अगर गिवन प्रोबेबिलिटी के बराबर आ रहा है देन वील कीप इट बिलो द गिवन प्रोबेबिलिटी. ठीक है. Another option for variable length coding is Shannon-Fano coding. Shannon-Fano coding also works in a similar way, but again it gives me the variable codes. We again take the example of the word committee, so that I have the probabilities given as this COIMTT. Higher probability on top, that is MTECOI. MTECOI. This is 2 by 9, 2 by 9, 2 by 9, 1 by 9, 1 by 9. For Shannon-Fano, what we do, instead of joining the last two probabilities or adding the last two probability, we try to divide the source symbols into two classes, such that the summation of each group or summation of each class is almost equal. Summation of probability for each class. For example, there are 6 symbols. The simplest case for division would be I divide the symbols into two classes such that 3 symbols lie to class 1 and the rest 3 symbols belong to class 2. But if I use this division, then the summation of probability here is 3 by 9 and here it is 6 by 9. The two are very much different. So instead I should divide the set of symbol into two classes such that the sum of probability for each class is as close to each other as possible. So if I divide the set here, then the sum of the probabilities on class 1 is 4 by 9 and here it will be 5 by 9. That is the closest I could have achieved. Right? I could have divided it here also, but then this will be only 2 by 9 and this will be 7 by 9. So that would not be a good option. I want the division such that the two sets, the two classes are equally probable, as close as possible. When I do that, I have the two symbols lying in this class. So in the next step, I further divide my class into subclass such that again the two should have the same probability. So it is 2 by 9, this is also 2 by 9, so that is fine. I divide it here. Now when I need to divide the class this side, I have different options. I can divide the class here, I can divide the class here. If I use this division, it would be 2 by 9 and 3 by 9. But if I use this division, it would be 3 by 9 on top and 2 by 9 at the bottom, right? So we can have any division done. Generally, when we are dividing, we keep the higher probability on the top. So rather than choosing this division, I should choose higher probability on the lower side, so that I have lesser number of bits assigned to high probability. So I will choose this method division, so that this set gives me 2 by 9, this set gives me 1 by 9. So the next division is here. How do we differentiate between them? Just like your Huffman coding, we keep on adding one bit every time on every step, right? But for Huffman coding, we were moving backward. For Shannon-Fano coding, we will be moving forward. So when I say we need to move forward, this means that when I divide this in the first step, I give one class the bit value 0 and other class the bit value 1. Right? Now I further divide this into two subclasses. So in the second step, I give one of the class value of 0 and the other class a value of 1. right? So what is the code that is assigned to M? This is now 00. For T, it is 01. For ECOI, I further divide the uh, class into subclasses so that one class gets a 0 in the next step and the rest gets 1. Now this cannot be further divided because this is individual. So now in the third step, I will divide the last 3. Now again I have this division followed, so I'll give it a 0 and 1 1 here. Why do I choose this? Because here it is 1 by 9 and here it will be 2 by 9. Further I divide it in the fourth step. This is only a single symbol in the class, so I need not divide it further. But now I divide this further to 0 and 1. So what is the code book that I generated now? MTECOI is the code for M. M is given as 00. T is 01. E is 10. C is 110. O is 1110 and I is 4 times 1. So this is the code book which is generated using Shannon fano, which has variable length coding. Again, to check the efficiency of the coding, we need to calculate the average length. Average length will be calculated by the length of every symbol multiplied by its probability and taking the sum. So what will be the L average for this question? The symbol M has two bits with the probability 2 by 9. So the first value will be 4 by 9. The length of the second symbol T is 2 and the probability is 2 by 9. So again 4 by 9 plus 4 by 9 plus 3 by 9 इसलिए because for C I am writing for this as I have length equal to 3 and probability equal to 1 by 9, so 3 by 9. Then I'll have 4 by 9 plus 4 by 9, right? This gives me the average length, right? Whenever we are having any coding method applied, the average length needs to be higher than the entropy, or I say the efficient coding method is the one where h gives me the lower bound on my average length. इससे कम नहीं कर सकती मैं lower the average number of bits, right? So entropy of the source gives me the lower bound. Entropy of source is the lower bound on the average length for the source. This is referred to as Shannon's theorem. You must have studied it when we are studying the coding. कोई भी हमारा coding method है that has to follow Shannon's theorem, the average length for the symbols can never go beyond the entropy of your source. ठीक है? Now the problem is, with these two methods of coding, the number of bits is always an integer. The value is always an integer, right? We have another class of coding which we call arithmetic coding, which uses value to define a word, again based on probabilities of symbols. So now instead of sending out number of bits for each symbol, like E के लिए 10 ना भेज के, I will send a typical value which will be representing the entire word committee. right? So number of multiple bits need not be sent, but I will send a particular value which I will call a tag. So arithmetic coding uses these tags which will be generated for each word based on the symbol probability. Let's take up an example. I have say 4 symbols A, B, C and D. The probability is given as 0.4, 0.2, 0.1 and 0.3. Right? Now I need not arrange them in any order of probability, but in any case, if I have the order given to me for the symbol, I should start working. So if I have in the first step the range of probabilities from 0 to 1, then from 0 to 0.4, if the number lies between 0 to 0.4, I say the symbol is A, right? So it means any number which lies between 0 to 0.4 will be used as a tag for a single A being transmitted. Above that, if I have any number between 0.4 and 0.6, which gives me an interval of 0.2, right? So if I send out any number between these two values, that number will be the tag for a single B transmitted. Similarly, if I have any number between 0.6 and 0.7 with an interval of 0.1 as shown here, I will have the tag generated for C. So this is A, this is B, this is C and this is D, right? But suppose I have multiple symbols sent. I have the word dad sent, right? Now I need to generate a tag, a single value which will represent this word. अभी अगर मैं फर्स्ट लेवल पे हूँ तो ए अगर मुझे ट्रांसमिट करना है तो आई शुड हैव ट्रांसमिटेड एनी नंबर बिटवीन 0 to 0.4. 0.3 will be the tag for A, 0.2 will also be a tag for A. So any number between 0 to 0.4 will be taken up as a tag for A. But now since I have the word to be given out is dad. So I know that the first alphabet or the first symbol is D. So my number should lie somewhere between 0.7 and 1. So I expand this interval now in the second step. Considering this as the complete interval, this is 0.7, this is this is 1. Right? Now I divide this entire interval in the same proportion as I have this interval. Okay? So the entire interval 0.4 is the first division, right? So 0.4 of this, that would be 0.4 of the difference 1 minus 0.7. How much is this? 0.12. So add 0.12 here. So this would be 0.82. So now any number which lies between 0.7 and 0.82 will be used as the tag for transmitting A after D. So DA, if it is to be transmitted, I should send out a number between these two values, right? This gives me the interval, right? What would this interval be? What would be the next division? Next division is 0.6 times the entire range. So what is the range? Range is 0.3. I multiply it with 0.6, that is 0.18. So I add 0.18 to this. So 0.88. Okay. 0.7 into 0.3, that is 0.21. So the next division would be 0.91. So I add the whatever I get here, I add this to 0.91. 7. Fine. So now I have transmitted D, so I will spread out 0.7 to 1, then more precise value will be given based on the second symbol that I need to send. So the second symbol is A. So I now know that not only the value should lie between 1 to 0.7, but since A is being transmitted, the value should be more precisely between 0.7 and 0.82. So for the third symbol to be considered, I spread this range again so that this begins at 0.7 and this ends at 0.84. What will be the first interval? The first interval is zero point 0.4 times the entire range. So what is the first value? 0.4 into 0.84 minus 0.7. So how much is this?
Ma'am, why is it 0.84?
8282.
Shouldn't it be 0.2?
This should be 0.82 because I'm spreading this range. So this should be 0.82. So the difference is 0.12 into zero point 0.4. So this is 0.048. So I should add 0.0482 to zero point 0.7. So what is this interval? 0.748. Right? So any number which lies between zero point 0.7 and 0.748 will be the tag for DAA transmitted. Okay. What would be the next interval for B? That is 0.6 times the difference. So the difference was 0.12. This is 0.82. So the difference was 0.82. 0.82 into 0.6 is 0.072. So this would be 0.772. So any value between 0.748 to 0.772 will be the code for DAB. I want the code for DAD. So what will I have here? 0.7, that is 0.784. So if I want DAD to be transmitted, I should have a number which lies within this range 0.784 and 0.82, because I have spread out D, then I have spread out A, and then I have spread out D. Now to define a rule, I always say that whatever is the last range I get, take the average of the two ends. So what is the average value that needs to be sent? 0.82 plus 0.784 divided by 2. This is my tag value. कितना आएगा ये? 802. So I should be sending out 0.802, only this value, so as to represent that I have transmitted that. This is very much efficient when I have the longer words, but the only problem is as the word length grows, as the number of symbols in the word grow, the number of decimal places also grow. Right? Because I am always spreading out the range of probability, which is always from 0 to 1. So at every step I am adding another place to decimal. यहाँ पर मेरे पास 1 decimal place तक value था. In the next step I have the values specified to 2 decimal places. In the next step I have the values specified to 3 decimal places, and so on it will grow. So this is generally useful when I have small words but with more symbols. Right? The decoding will be very similar. For decoding, what we do is we are already having the code given to us, or already having the this tag given to us. Suppose I have my input as 0.742. 0.742 if is my input. So what I do is I try to find in the first range where this number lies. 0.742 will lie in this interval. So if the number lies in this interval, I know that my first symbol transmitted is D, right? So I spread the range for D now. When I spread the range for D, I again look out for this value 0.742. 0.742 lies in this region only, right? So what do I know? That I must have transmitted A. So I spread the range for A. A has been taken up and I spread the range for A. Now again look out for the value for 0.742. The 0.742 value will lie in this range, right? It means what must be the symbol that I should have been transmitted? It should have been A. So my next considered symbol is A. Since I have three decimal places, I have got three symbols. So I'll stop here and I will say that this is the value which was transmitted and had the tag of 0.742, right? You need to simply spread the probability range again as you did for coding. The advantage that we get over the previous methods was in the Shannon fano and your Huffman coding, every time while
Excuse me,
you are,
ma'am.
yes, child,
Ma'am, about decoding, can you once again explain the second step after T, like 0.74? So how come this A?
the value for A will be from 0.7 to 0.82. So where will you have this value lying in the range 0.742? It will be above 0.7 and
Yes,
below
ma'am.
0.82. So it means
Okay.
this is the range,
Okay, ma'am.
and so you will spread this range. ठीक है अगर value if your input was 0.873, so the first thing is where is 0.873 lying? Again D here. So the first alphabet or first symbol would have been D. But now in this range, in the second step, where will 0.873 lie? 0.873 will lie in this range, 0.82 or 0.88 के बीच में. Which means what was the symbol used? The symbol used for was B. So now in the next step, you will spread the range for B. In the same way as you did for A, you will spread the range for B now, 0.82 say 0.88. Wherever this value lies, that will be your new or the next symbol. Right? Division इसी तरह करना है. Based on the ratio of the division in the first case, you will again divide the entire range, but now for the symbol B. ठीक है? So you can check out what would be your third symbol. Now, we were talking about the advantage that we are getting for arithmetic coding over the Shannon-Fano and Huffman coding. If we look at Shannon-Fano and Huffman coding, once we have done the coding, I need to send this code book so as to be able to decode any symbol. Right? अगर मेरे पास ये code book नहीं है, then I may not be able to decode the symbol because I have these three probabilities equal. Someone may have put the sequence as MTE, someone may have put the sequence as the alphabetical order EMT. In that case, if the arrangement is EMT, then E gets the code 00, right? So every time for decoding, I need to exchange my code book. The same is the case for Huffman coding as well, right? But for arithmetic coding, I need not share anything. I just need to have these probabilities given to me. So no sharing of codebook is required for arithmetic coding. ठीक है? Any problem in arithmetic coding? You can have a look at the questions that are given in different books. I'll provide you with one assignment on this compression as well. Fine. Here we are not interested in finding the length, average length, because this does not fall into the class of variable length coding because we are not giving the code for symbols. Instead, we are giving the codes for words. Fine. These are the three methods of coding. Then comes the fourth method, that is again a dictionary based coding. Just like your arithmetic coding, we need not distribute the code book when we are using dictionary based coding. The example is LZW, that is Limple Ziv Welch coding. This coding method uh, does not take care of the probability, it does not require the probability, it does not require anything. It just requires the data that it needs to transmit, and then based on the frequency for which the values are repeated, it will generate its dictionary. For example, suppose I need to send this, right? I have only two symbols, fine. But suppose I have my dictionary. The dictionary has two entries already, that it is A is coded as 0 and B is coded as 1. But later on, if A is followed by B multiple times, for example here A is followed by B, A is followed by B, then what dictionary coding does is it keeps on adding uh, it keeps on adding the modified versions. Just a minute. So you keep on adding the codes to your dictionary. It means, like, if A is transmitted, you will say a 0 is sent out. If this is my input, what will be my output? What is the code for first word? It is 0, right? The second word is B. So in my dictionary, I know the code for B is 1. But at this point, I will add a new symbol now and will say that the A followed by B, if generated in future, this should be given the code 2, right? So that every time when A follows B, I need not send 0 and 1, instead I send 2 only, right? So now comes the third alphabet. Third alphabet is B. I look out for the code of B in my dictionary. B is 1. So I say I will transmit 1 again, but now at the same time I will add the new symbol which says that in future if B follows B, simply give out the code as 3, right? Rather than giving the code for B and B two times, encode them as a pair and give the value equal to 3. Fine. The next value read is A. I look out for this A. I have two options in my dictionary now, A and AB. So rather than using this value of single A, it would be the data will be compressed if I use the combination. So now instead of sending out the code for A only, I try to combine it with B. I try to combine it with B so that the new symbol that I look out for in the dictionary is AB. So AB is already given the code 2. So I need not transmit 0 followed by 1. Instead, I'll simply transmit 2, which means I have transmitted the symbol AB. But at this point, I need to make an addition to the dictionary. So now what the addition would be, whatever is the previous thing that I sent out. This was A, this was B, this was B. So what is the new entry to the dictionary? B is followed by AB. So now I have a longer combination added to my dictionary, so that in future, if I have B, A, B together, I should directly give out the code equal to 4, right? But I can add at every step and use that after that step only. So if the next case is BAB, I cannot use it directly because अभी मैंने इसी step पे add किया है. एक step पे जब मैंने add किया उसके बाद अगर कहीं BAB आ रहा है, then I will use this new code 4, right? So now I have the new word B. I have options for B now. I can have single B, I can have 2B, and I can have BAB. So I'll try to look out if I can have any of these possibilities. So I combine the next symbol. So BA. So I will not transmit this 1 followed by 0. Instead I look for BA. But BA does not exist. I can have this code utilized now because this was added in the last step. So I look out for if I can have this code used. So I check for the third symbol also and I'll combine this. So now BAB is found. So I'll simply send out a code for BAB, which is 4. Right? So I will send out the code as 01124. Every time this dictionary will keep on growing, we would only require the initial thing. So अगर मुझे 01 पता है, so in that case I will reconstruct the dictionary at the receiver end in the same way as we do for the transmitter end, and the dictionary keeps on growing, so that in future if the length of combination of symbol is increasing, I can have the smaller codes defined, right? Smaller code कैसे हम कह रहे हैं, अभी मेरे पास कितने codes आए, 5 codes, so I need 3 bits, right? So when I have this BAB transmitted, I will require to transmit only 4 bit. अगर इसके बाद मेरे पास और sequence बड़ा होता, suppose I'll get the last entry would be AB followed by BAB. That would be given as the code 5. So now instead of transmitting 5 values, I will transmit only 3 bits. वरना इसके लिए मुझे क्या transmit करना पड़ता, 1 bit for each symbol. So A के लिए 0, B के लिए 1, then 1, 0, 1. तो अगर मैं code नहीं use करती, this would be requiring 5 bits. But now I have used the coding. So what is the code for 5? It is 101. So I only require 3 bits to be sent out for the 5 symbols combined together. So as this data grows, as the length of the data grows, this method becomes more and more efficient. Right? Transmission में हमें कुछ नहीं करना है. The dictionary will always be generated by itself during the decoding as well, right? We'll look into the decoding of this LZW in the next class, and then do 2 more methods of coding and finish with the compression in the next class. उसके बाद we'll start with the segmentation, 1 class for segmentation, 2 for morphological processing, and 2 for colored image processing. So by next week we will finish with the syllabus. You please start studying for your theory exam. Do the practice for questions.